Standing at the edge of a coastal battlefield, a Blastoise plants its feet into the sand. The cannons on its shell rotate forward. In less than 1/10 of a second, twin streams of water erupt with the force of artillery fire, punching through solid concrete like it was paper. How does a living creature generate this much power? The answer lies in one of nature's most sophisticated hydraulic systems, a biological weapon that blurs the line between evolution and engineering. From the moment a war turtle's shell hardens and splits to accommodate twin cannons, everything changes. The transformation into Blastoise isn't just about size. It's about becoming a mobile siege engine. Those cannons, each roughly 10 centimeters in diameter, emerge from the shell's surface like periscopes on a submarine. They can extend, retract, and aim independently. But their true marvel lies beneath the surface. Inside that massive shell, approximately 650 litres of water sit ready for deployment. That's enough to fill 3 bathtubs. The shell itself is ellipsoidal and carefully shaped to distribute both storage capacity and structural integrity. Half the interior volume houses organs and muscle. The other half? Pure liquid ammunition. Yet water alone means nothing without pressure. Here's where Blastoise's anatomy becomes truly extraordinary. Specialized muscles lining the interior shell contract with incredible force, generating pressures that would make industrial engineers jealous. We're talking about 360 pounds per square inch minimum, enough to launch water at speeds exceeding 250 kilometers per hour. That's faster than most professional baseball pitchers, but some calculations suggest the reality is far more extreme. When Blastoise fires a full-power hydro pump, the water may be travelling at 825 meters per second. For perspective, that's the velocity range of actual cannonballs from historical artillery. A fire hose shoots water at maybe 30 meters per second. Blastoise is operating at nearly 30 times that force. The impact. Roughly 4 million pounds of force concentrated into a stream 20 centimeters wide. Steel buckles, concrete shatters, solid rock erodes under sustained fire. These aren't exaggerations, they're documented observations from battle after battle. But here's what makes this even more fascinating. Every action has an equal and opposite reaction. When Blastoise fires, the recoil should send it flying backward at over 100 miles per hour. A force that violent would launch most creatures across the battlefield like a kicked ball. So why doesn't Blastoise move? The answer reveals an evolutionary adaptation so elegant it borders on genius. And it explains why Blastoise grows so impossibly heavy in the first place. Blastoise deliberately packs on mass. Every pound serves a purpose. The average Blastoise weighs nearly 200 pounds, but battle-hardened specimens can exceed that significantly. This isn't fat or excess, it's ballast. Pure functional weight designed to counteract physics itself. The legs tell the whole story. Thick, muscular, built like support columns. The back broadens and strengthens throughout its life. These adaptations exist for one reason: to absorb recoil that would otherwise turn the creature into a tumbling projectile. Friction becomes Blastoise's greatest ally. Those massive feet dig into earth, sand, even concrete. The more surface area in contact with the ground, the more resistance against backward motion. It's why you'll never see a Blastoise firing while airborne unless it wants to fly. And fly it can. Turn those cannons downward, fire at full power, and suddenly you have a biological rocket. Calculations show Blastoise can reach 28 meters, 10 stories, using just its stored water reserves. The same force that punches through walls becomes thrust. The same recoil that threatens stability becomes lift. Its propulsion and weaponry sharing the same mechanism. But the system has limits. Each full-power hydro pump drains the reserves in barely 1/10 of a second. That's why accuracy matters so critically. There's no time to adjust midstream, no room for correction. Blastoise fires and the shot either connects or it doesn't. This explains why, despite devastating power, the move carries inherent risk in battle. Then comes mega evolution. The transformation doesn't just amplify strength, it restructures the entire cannon system. The twin back cannons merge into a single central barrel that extends forward over Blastoise's head. 2 additional cannons emerge from armored gauntlets on each forearm. 3 weapons instead of 2. The central cannon alone matches tank artillery with a documented range exceeding 6 miles. That's not a creature anymore, that's a mobile weapons platform. The personality shifts too. Mega Blastoise grows more aggressive, more willing to unleash maximum firepower. Whether this stems from increased confidence or the sheer power coursing through its body remains unclear. What's certain is that the restraint shown by regular Blastoise often vanishes. From hydraulic principles formulated in 1650 to modern industrial water cutters, the physics remains consistent. Pressure multiplied by area equals force. Blastoise's body evolved to maximize that equation. Compress water, focus it through narrow openings, and the result rivals human engineering at its peak. Standing on a battlefield, cannons aimed forward, Blastoise represents something remarkable. Not just evolution adapting to survival, but biology achieving what typically requires metal, machinery, and human ingenuity. Stay tuned for the next episodes to discover more details about these incredible creatures. The weight, the cannons, the hydraulic precision. Every aspect of Blastoise's design answers a single question. How do you turn water into a weapon without destroying yourself in the process? Evolution solved it through mass, muscle, and physics working in perfect harmony.